Today in pre-cal we talked about sketching graphs. There are a few steps we should start with. The first is to apply the leading coefficient test. So figure out what the degree is it even or odd, and is it the coefficient positive or negative? And then figure out what the arms are doing from there. We made a good chart of that yesterday, so if you need to check that, do that again. B, to find the real zeros. So factor out your problem, find the multiplicity, and figure out whether it crosses, touches, or flattens through that piece of the graph. Part C, to plot a few additional points or a few extra points around where you plotted those real zeros. And part D, to graph it continuously, meaning you put a smooth curve through it. Let's look at an example of this. If I have f of x equals 3x to the fourth minus 4x to the third. Okay, it's not in factored form. Its highest degree is 4. The coefficient of that is 3, so it's even and positive, which tells us for part A that both arms are up. For part B, we want to factor it. We should notice that these two things have in common x to the third power. We can factor that out. What remains is 3x minus 4. I can set both of those pieces equal to 0, so x cubed equals 0 and 3x minus 4 equals 0. If I solve, I will get that x equals 0 and x equals 4/3. I want to do their multiplicity. On this one, the multiplicity is 3 because it's to the third power. This one has multiplicity of 1. Okay, and let's see if I can get more of this in your view. Let's go. And you can see the multiplicity is 1 right here. And if it has multiplicity of 3, it flattens. And multiplicity of 1, it crosses. For C, pick a few points around that. Okay, a few points around 0 would be like -1 and 1. And 1 is also in between 4/3 and the next biggest number, which is 2. So I'm going to find f of 1 by plugging in 1 everywhere I see a value. And I would get -1, so we have the point 1, -1. If I plug in -1, I get 7. Guys, you could follow that process through or use your calculator. Either way would be fine on that. If it was on a non-calculator section of your test, obviously you would need to work that out. None of these are too large numbers, so you should be able to do that. And if I do f of 2, I would get 3 times 2 to the fourth minus 4 times 2 to the third, and I would get 16, which is a fairly high number. Now, if I want to graph this, I'm going to take all the information I've just been given and get a good graph. I know in the end, both of my arms need to end up, like so. I also know that there's something happening at 0 and there's something happening at 4/3. So I'm going to put a point at 0. And I'm going to put a point at 4/3. You'll notice that I put my 1 right there, so I'm just putting a little bit further because 4/3 is just 1 1/3. Okay, now, what happens? Well, at 0, it flattens through the graph, and at 4/3, it crosses the graph. I can also plot my points that I just got, which were 1, -1. I'm going to go by 2's on my y-axis so I have enough room. -1 and 7. And 2 and 16. Which is way up here. I know both arms end up, so I'm just going to do here at 0. I know it flattens through the graph, so it's not just straight through. Flattens through here. Okay. And then crosses straight through at 4/3. And there's a sketch of what my graph might look like. Now, mine and yours maybe look different if you use a different scale than me, and that's okay. But in general, as long as this flattens through, this crosses through, and both arms end up, that is kind of what your graph would look like. You can always put it in your calculator to double check that you got that correct. Let's try another example. I want you to see another one of these. So if I look at example 2, I have that f of x equals -1/2 x times 2x minus 3 squared. This is already in factored form, so it's going to be hard to tell the degree. Let's think about what would happen if we multiplied this out. If we FOILed this, which is what it means to square, I would get 2x squared times, or 2x times 2x would be 4x squared, times another x would be x to the third, and this is positive 4 times -1/2 would be negative. I don't really care about the numbers, I just want to figure out the degree and the sign. So it would be to the third power, and it would be negative. And so we know that it would be where it, it would be where it rises left and falls right. Okay, the arms would go in different directions and it would start up and go down. That's what we know about negative. For B, get it in factored form and solve. It already is, so we're going to set each piece equal to 0. If I have -1/2 x equals 0 and 2x minus 3 equals 0 on the first one, I would multiply both sides by negative 2 and I would get that x equals 0. On the second, I would add 3 to both sides and then divide by 2. My second x value is x equals 3 halves. If I look at their multiplicity, here the exponent is 1, so it's multiplicity 1 and it crosses. On the other one, it has squared, and so it's multiplicity 2, and it just touches at that point. Part C is to get a few more points. So points around 0 and around 3 1/2, or 3 halves, I'm sorry, would be like negative 1, 1, and 2 would work again. So if I plug in negative 1, I get 12.5. If I plug in 1, I get negative 1/2. And if I plug in 2, I get negative 1. Again, that's just solving things in f of x form. I think you're familiar with that. If not, I'll be happy to show you that again sometime in class. I've got 3 points. Now I want to go ahead and graph this thing. So I'm going to use what I know to graph here. I know that there is a 0 at x equals 0, and there's another one at 3 halves. Sorry, I keep saying that incorrectly. So those two are my 0 points. I know that in general it's going to come from up and it's going to go 2 down. So I'm going to make those little arrows just to help me keep in my mind. I'm going to plot my other points from part C. So I have negative 1 and 12 1/2. So negative 1 and right here. And then I have 1 and negative 1/2, which would be about here. And then I have 2 and negative 1, which is here. Okay, I'm coming from up. At the point 0, the multiplicity was 1, and so it crosses straight through here. Crosses like that. It's got to connect to this point, continuous curve. At the point 3 halves, it touches. So it's going to touch here and bounce back down to cross through that other point and go straight down. And in general, that's what my graph will look like. Again, you can always check that in your calculator. Our assignment for this is A6, page 149, 73 and 74, 77 through 80. It's just a few problems. I need you to get those done and make sure that you understand them. Ask questions if you don't.